morning, and thank you for joining us for a live talk with David, who is the Outreach and Education Manager at Spaceport Cornwall. If you don't know, it's the UK's horizontal launch station. It's great to see so many of you joining us today, and we are sure you will enjoy this exciting webinar. To celebrate, and today is the last day of World Space Week, David will be talking about the UK's first ever attempt to launch a satellite and rocket into space from UK soil, which you may know took place in January of this year. Lots of press coverage about that. Please feel free to ask any questions by putting them into the chat, and David will aim to answer as many as he can at the end of his talk. He's also got something a little exciting that he'll share with you as well, but more about that from David. So that's enough for me. I will hand you over to David. Good morning, David.
Good morning, Lisa. Thanks very much for the introduction. I'll make a start. Nice to be beamed into all the classrooms across the country. Thanks very much for having me today. So today I'm going to talk to you a little bit about Spaceport Cornwall, who we are, what's been happening. So I'm going to give you a presentation for about 20 minutes. Then we've got a quiz, which is going to take about 10 minutes. And then, as Lisa said, we've got a Q&A, which is going to be the last 15 minutes. So please do think of any questions you've got and type them into the Q&A box whilst I'm presenting. So just a little bit of information about me and my journey into the space sector. I studied business development at university after doing A-levels in business, sociology and psychology. And I've written after some challenges there in brackets. And those challenges were that I actually failed all of my AS levels. I went from school to college and I just didn't work hard. And I failed all of my AS levels and I had to retake year 12 again. And it was a bit of a story of hard work and being able to bounce back and go again, which is going to be a bit of a theme of this presentation. But bounce back, chose some different subjects that I was more interested in, then managed to get decent grades and went on to university at Bath Spa. After university, I worked in college recruitment, newspaper circulation management, university engagement, and then finally as a business and education development manager, so linking businesses with education so that students have more of an idea about the different types of job opportunities that there are for you, and so you can see what you can be and really, get an idea of all of the different types of roles that are out there. Whilst I was working in that role, I started to do some work with the space sector here in Cornwall, and that's really what got me passionate and excited about Spaceport Cornwall, because I can see a real opportunity for the whole of the UK to develop even more in the space sector and create some incredibly exciting and high-paid jobs in the sector as well. So I'm going to talk to you about what Spaceport Cornwall is, and then a little bit more about the space sector and the different types of jobs in the space sector as well. So what is Spaceport Cornwall? Spaceport Cornwall is one of the 7 spaceports that are being set up across the UK. So about 8 years ago, the government asked for different areas if they'd be interested in becoming spaceports, because we had no spaceports in the UK. And these 7 areas that you can see on the map were chosen. So you've got us there down in the far southwest, and we're a horizontal launch spaceport, which means that rockets will take off on the wing or inside of a plane, fly up to about 35,000 feet, and then those rockets will be dropped and then power off into space. And then up in Scotland, you've got a couple of vertical launch sites. So you've got Shetland and you've got Sutherland, right at the very top there, the blue and the green. And between us 3, we're sort of the furthest ahead in regards to launch. So we've actually attempted our first launch, and Shetland and Sutherland should be launching sometime next year or the year after. So really exciting time for UK space and for the UK to have that capability of launching some of the satellites that we manufacture here and in Europe to be able to be launched from the UK. So this is what the actual spaceport looks like in Cornwall. So like I said, it's a horizontal launch spaceport. So we're actually based at Cornwall Airport, Newquay, and we use the same runway that the normal airplanes use to take people on their holidays. And Cornwall Airport Newquay was chosen because it's got one of the longest runways in the UK. It's got a fairly uncongested airspace above it, and it's got almost direct access over the sea. And that's really important because the sea is a safe zone when it comes to launching rockets. All of the spaceports will look quite different around the UK. So one of Scotland's is here. This is the vertical launch site. So you can see that their vertical launch pad is there in the middle, and they've got some supporting buildings sort of out on the edge of the land, again close to the sea. So they've got that safe zone for being able to launch rockets. I thought it'd be best to show you what a launch does look like from Cornwall. If you did see in the news in January about the launch from Cornwall, you will have seen that it wasn't 100% successful. We actually had an anomaly in the second stage of the rocket, which meant that it didn't actually make it into orbit. But Virgin Orbit did have 4 successful launches prior to coming to Cornwall, and I just wanted to show you what one of those looks like.
Elsie, this is LDN Control Room. We are currently on track for our nominal timeline, and our current drop time as listed in Trillion is 19:25 UTC.
Planet controller on flight crew has been boarded the aircraft.
Cosmic Girl, this is orbit base. You are go for takeoff.
Copy, go for takeoff.
Altitude 3000.
And orbit base, Cosmic Girl is starting the turn to the inbound. Pulling now. Pull.
Pulling.
Release.
Release, release, release.
Release.
EST's ignited.
Confirm Newton 3 engine startup.
Max Alpha achieved.
TBC's in first stage looking good.
We had a pretty awesome view up here.
Max Q Alpha achieved.
Stage 1 burn nominal.
Stage set, brake wires broken.
Newton 4 startup complete.
Recovered, and we are now returning to base.
Bearing, brake wires broken.
Launcher 1's in space.
Sounds like the blue skies on purple.
This is Radiohead on control. Mauritius has confirmed acquisition payload separation confirmed.
So that was Virgin Orbit's first successful launch in January 2021. And this is all about launching satellites into space, not people. So satellites that can help us back here on Earth in regards to communication, to tracking things, to monitoring the environment. And this is when we were gearing up for our first launch in January of this year. So you can see the satellite integration facility there behind Cosmic Girl, which is a Boeing 747-400. And the integration facility is where the 72-foot Launcher 1 rocket gets loaded into one side. The satellites, the payloads, get loaded into the other side of the building, and then they meet in the middle in this giant clean room. And the nose cone of the rocket comes off, gets lifted vertically, and then the payloads get put into the nose cone of the rocket. These are 2 of the real payloads that were on that first launch. So we had 9 satellites that were on the first launch, and these were the 2 of the real ones. And I think when I talk about satellites, a lot of people picture something the size of a washing machine or a car or even a minibus. But nowadays, satellites can be the size of your lunchbox and carry out many of the same types of things that much larger satellites in the past could do. And that's because technology is advancing. If you think about the technology that is now in our mobile phones, is now in our computers, and how that has advanced over your short lifetimes, it's the same that goes for satellites. So it's able to get smaller, lighter, and makes it more cheap to actually launch those into space. So I'll just talk about 2 of the 9 that were launched, just to share some of the different ways that satellites can be utilized. So one satellite was from a company called Spaceport, which is based in Wales. And they're looking at in-orbit manufacture, so actually 3D printing semiconductors that go into our chips in our phones and in our computers, 3D printing those in space to then be able to bring them back down to Earth to be able to use. And the benefit of doing that in space is that you've got a lack of gravity, so you can make those fine motor movements more easily. You've got a super clean environment because space is a vacuum, and you've also got the extreme temperatures. Whether you're facing that satellite towards the sun or away from the sun, you can get extreme hot and extreme cold, which makes it a really good environment for doing things like that. And SpaceForge thought that they could actually create those semiconductors in a 50% more carbon efficient way in space than on the ground. And they're still looking to do that. So really exciting technology. And then another company called Horizon, they were actually looking at pirating in Somalia and using satellite phone signals that pirates use in that area to be able to find out what's happening, what's going on, and to indicate to authorities in Somalia about what's happening to crack down on pirating in that area. So two very, very different uses of satellites, but two quite interesting differences there as well. As we were gearing up for launch, we had 350 of the world's media down on site. You probably saw something in the news maybe earlier this year. We also had 2,500 people up on site. This was on January the 9th at midnight, because we could have either launched at midday or midnight, because the orbit that the satellites needed to get into, those were the perfect times to be able to launch. We chose midnight because it's still an operational airfield, so we didn't have to divert any flights to be able to launch at midnight. And everything was going perfectly. Cosmic Girl took off from the runway, dropped the rocket. The first stage of the rocket burned for 3 minutes as planned. That fell away, and then the second stage of the rocket started to burn. That should burn for 6 minutes and then get up to its maximum speed. But it wasn't able to get up to its maximum speed, and we all heard on the big screen that Launcher 1 has suffered an anomaly and will not be making it into orbit tonight. We were pretty devastated. Some of us had spent 8 years working on the spaceport and working on making this launch happen. It took us a couple of days to really bounce back and start to think a little bit more positively about what we've achieved. And the things that we've taken away from it is that we've had an opportunity to learn from our mistakes. You know, we can make the next launch better. Sadly, since this launch, Virgin Orbit have actually gone bankrupt, but we've got other horizontal launch partners that we're working with. And in the same way that the airport has multiple flight partners, we're looking to have multiple launch partners from Cornwall in the future. We've demonstrated that the spaceport is operational, and we were the first licensed spaceport in Western Europe, which is pretty massive to have in the UK, the first licensed spaceport in Western Europe, because that means any European rocket companies are going to be interested in working with the UK in regards to launching. So the two Scottish sites have got 2 European launch partners that they're working with to launch into space. And the UK now has direct end-to-end capability of not just developing satellites, but also launching them. So not many people know that Scotland actually manufacture more small sats than anywhere in the world apart from the US. The UK really is quite a powerhouse in regards to space and space developments. Overall, for us, it's been a story of resilience and to never give up, to bounce back, to go again, and to make it better next time around. And I think this is a really important message for you guys to learn whilst you're going through your education as well, because you may complete the best piece of work that you've ever completed, submit it, and not get the grade that you're anticipating. But you use that piece of work, you bounce back from that, you make it better next time round, you learn from it, and then you will get the better grade that you want to get next time. So really important lesson to learn that sort of message of resilience. So what's next for us? So we've developed a space cluster here in Cornwall. We've developed a centre for space technologies, so an operations facility and an integration facility. And in the operations facility, we've got space businesses setting up and developing out of that space. So we're working with a few of the companies that you can see on screen here. So we've got Avanti Communications. They're actually communicating with some large satellites, so much more like a car or like a minibus up in geostationary Earth orbit from our site. The bottom middle there is a company called Sierra Space, and that's their Dream Chaser. They fly astronauts and research missions up to the International Space Station, but they're a vertical takeoff, so they take off on the nose of a rocket, but a horizontal land, so they come in and skid land. And we're hoping that we're going to have a 2027 land with them where they've got UK research missions or UK astronauts on board that will come back to Cornwall, and then we'll be able to process that research on site as well. And then top left there, we've got a company called Space Engine Systems. They're a Canadian company, and they're looking at something called point-to-point travel. So you may have seen in the news recently, there's a number of companies that are looking at point-to-point travel. So using the edge of space or using hypersonics to get from the UK to the US or to Australia in a matter of hours rather than a day. And Space Engine Systems have set up in one of our hardened air raid shelters, and they're developing their technology in one of those areas. So really exciting things happening on the ground still in regards to that cluster development. But why is all of this happening? Why are we launching more and more satellites into space, and why are we hearing more about satellites? It's because satellites are the game changers. We're all using satellite technology more and more every single day. Highly likely that you've all used satellite data in some way already just this morning, whether that's getting to school and your parents or your bus using the GPS, or if you've had certain cereals or certain wheats for your breakfast, highly likely that they've been grown with the support of satellites and transported with the support of satellites. So some of the more novel ways that satellites are being used now, on screen there, we've got precision farming applications. So you can now use low Earth observation satellites. So satellites with a camera on them facing back down to Earth. Use those low Earth observation satellites to take really detailed images of a farmer's land. And from those images, the farmer can see what areas may need extra pesticides, may need extra fertilizer. So rather than using pesticides and fertilizer on the entire farm area, they're now able to really pinpoint those areas that need that. And that saves time, it saves cost, and ultimately increases yield. And in the future, who knows, that data could go to an autonomous vehicle that could then go and spray those areas automatically. And automated vehicles, you know, in the next 10 years, we're likely to see more and more automated vehicles on the roads. And that is going to be needing constant satellite data to be able to manage that. Something I'm very excited about because I'm not a huge fan of driving. So what does this all mean for you? What is the opportunity for you? So talking about jobs, and not just astronauts, that's Tim Peake on one side of the page. If you want to be an astronaut, go for it. Follow 100%, get all of that information, all of that data, and really, really work hard at it. And even if you don't end up becoming an astronaut, you'll find something that's super interesting and something really great within the space sector that you'll be able to go on to do if that's what you want to do. But I want to talk about some of the other types of jobs in the space sector as well. So things like spaceport operations, so people who manage the spaceports and manage the sites that are being set up around the world, because there's many spaceports being set up around the world now. Spaceplane and rocket systems, so people who work out how we get those rockets up into space. Payload integration, people who have their final touches on those satellites to make sure that they're going to work up in orbit when they get there. Propulsion systems, so if you like maths and science, working out what fuel and how much fuel is needed to get those rockets into space. And over the next decade, there's going to be a lot of movement towards more sustainable fuels. So a really interesting area to look into. We're launching all of these satellites into orbit and we're getting all of this data back. So downstream application development is really important because people who understand how to turn that data into something usable by fishermen, by farmers, by teachers, by industry, that's where a lot of the next millionaires are going to be made. Because if you can make something that works for one person, you can scale that all over the world. And aerospace engineers, if you like Lego and Minecraft and pulling things apart, putting things back together, engineering is that amazing mix of thinking creatively with your mind, but then using your hands to actually build the things and the solutions that you've come up with. And aerospace engineers are in short supply, as are engineers across the country. So, you know, have a look at that if that's of interest to you. I'm going to touch on to routes, although I think most of you are probably a little bit too young, so I'll go past this fairly quickly. There are some apprenticeships starting. So apprenticeships are when you can work and learn at the same time. So you'll be out in the workplace 4 days a week generally, and then in study for 1 day a week. So there are some apprenticeships starting across the country, but still a very common way into the space sector is through university. And the UCAS website is where all 37,000 unique university courses are advertised. Some of the ones that are relevant to the space sector include aerospace engineering, that's carried out all across the UK, space science and robotics, and that's robotics on Earth, but also robotics in orbit. So, you know, in the next 5 years, we're likely to have a manufacturing base on the moon. And if that's the case, we need robots to be supporting that as well. And then if you're interested in that downstream side, things like web and mobile app development are particularly pertinent. Spacecareers.uk is a really great website to have a look at if you're interested in careers in the space sector. And there were 70 advertised last time I looked. I think there's significantly more now because it's a bit of an old slide. But if you are interested in space, just going on there to have a look at what types of jobs there are can really help shape what you want to go on to do in the future and give you a bit of direction. A few recommendations from me are on the screen here. I think at your age now, the most important things that you can do are looking at competitions and challenges. So looking at competitions and challenges and European Space Agency competitions and challenges, taking part in some of those and getting that experience and seeing where they take you. Because you never know if you win a competition where it might take you. We ended up taking 6 students up to watch the Buzz Lightyear premiere and interview Tim Peake, Chris Evans and Taika Waititi, all from a small competition they entered in Cornwall. So have a look, don't just do the ones that your schools do, have a look off your own back and enter some, and you never know where they take you. A few things we've got coming up. So we've got a virtual reality experience that's just been launched, which shows the first launch. And we are going to be launching a satellite called KernoSat-1. There's going to be monitoring the ocean health around the Cornish coast to look at seabed restoration and looking at sea grasses. And that data we want to use to go into schools. So we're hoping to be able to launch that sometime next year or the year after. That's been a really quick whistle-stop tour from me. I hope you found that interesting. If you've got questions, I'd love you to write them into the question box. Now we're going to move on to a quiz. And this is a bit of an interesting one because I can't see you. But what we're going to do is we're going to vote with the quiz with our bodies. So if we can have silence across all of the classrooms everywhere and really concentrate on this part, what I'm going to ask you to do in a minute is everybody stand up. So stay sitting for a minute because you're going to vote. And we're going to have, if you think the answer is A, you're going to raise your left hand. If you think the answer is B, you're going to raise your right hand. If you think the answer is C, you're going to raise both hands. And if you think the answer is D, you're going to raise no hands. You're going to just be standing up and no hands up. And then if you get the question wrong, you're going to sit down and we're going to try and see who manages to get all of the questions right from the schools across the UK that have joined. And I'll remind you of these votes. So if everybody could please stand up, that would be great. Okay, so if we can have silence across all the classrooms, that would be great. So first question is, when did we have our first attempted launch from Spaceport Cornwall? So is it A, raise your left hand, 2020, B, raise your right hand, 2021, C, raise both hands, 2022, or D, don't raise any hands, 2023. Have a little think. I'll give you a couple of seconds. And in 3, 2, 1. So it's D, 2023. So it was this year that we attempted our first launch. So anybody who voted for D, stay standing. Anybody who didn't vote for D, please take a seat and we'll move on to the next question. So now on this one, don't vote until I go 3, 2, 1, and then everybody votes. So then you don't get to copy everybody else in your classroom. So next year, we're hoping to launch a satellite for Cornwall. What will it be called? Is it A, left hand, Satellite Cornwall 1, B, right hand, Good Space 1, C, both hands, KernoSat 1, or D, no hands, Sat for Good 1. So in 3, 2, 1, vote. It is KernoSat 1. So anybody with both hands up, please stay standing. Anybody without both hands up, please take a seat. We'll move on to the next question. So I haven't covered this in my presentation. This is one for you guys to think about now in your school. So when the rocket drops, so there's a 30-ton weight, that rocket. So when the rocket drops from the wing of Cosmic Girl, how does the plane rebalance? Is it A, left hand, people inside will move from one side to the other? Is it B, right hand, and equal weight will drop from the other side? Is it C, both hands, it will not need to rebalance? Or is it D, no hands, fuel held in the opposing wing will be used to rebalance? So have a think. And in 3, 2, 1, the answer is D. So anybody with no hands, please stay standing. Anybody with hands up, please take a seat. So the fuel all of the fuel is actually held in the opposite wing at takeoff. And then when that rocket drops off from the wing of the plane, there's a valve that opens in the middle of the plane and starts to pump the fuel through into the other wing. So a really, really simple piece of engineering, but works so well. Takes about 5 minutes, but then the plane can rebalance and be able to come back and land. Next question, what is the average salary in the space sector? So A, left hand, 39,000, B, right hand, 44,000, C, both hands, 49,000, or D, no hands, 54,000. Have a think. And in 3, 2, 1, the answer is C, £49,000. So anybody with both hands up, please stay standing. Hopefully we've still got a few across the country in. So 49,000. This is London weighted, so there's it's higher salaries in London, but that's the average salary across the UK. So now another one for you to think about, and this one's mind-blowing to me. So in 1977, there was a satellite called Voyager 2, and it was launched to explore our solar system. It's traveling at 35,000 miles per hour. So at 35,000 miles per hour, you could get from London to Cornwall in 20 seconds, just to give you a bit of an idea of how fast that is. It reached Pluto in 2006 and is now out past our solar system. When do you think it will next encounter a star? Is it A, left hand, 40 years? Is it B, right hand, 400 years? Is it C, both hands, 4,000 years? Or is it D, no hands, 40,000 years? So have a think. So A, left hand, B, right hand, C, both hands, D, no hands. 3, 2, 1. The answer is, incredibly, 40,000 years. And that gives us a bit of a, I mean, Voyager 2 will not survive for too much longer, probably, you know, a maximum of a decade or decades. But that would be when, if it was able to survive, when it would next encounter the next star. So that just gives you a bit of an idea of the scale of our solar system and of our universe. Okay, really important question now. What percentage of the 18 to 24 age group joining the space sector are females or non-binary? So this is the younger sort of age group that's joining the space sector. What is the percentage of females or non-binary people joining the space sector from that youngest age group? Is it A, left hand, 25 to 30%? Is it B, right hand, 30 to 35%? C, both hands, 35 to 40%, or D, no hands, 40 to 45%. Have a think. And in 3, 2, 1, the answer is 40 to 45%. So the space sector is changing quite significantly. I think historically it's always been associated as a fairly male-dominated sector, but now we're up to 40 to 45% of the youngest age group joining, being female or non-binary, and you know, we're trying to get that up to at least the 50% mark, and that's really positive to see. And I think, you know, space is for everyone. If you're interested in it, you can go for it, you can work in it, you can be in it, and it's super exciting. Okay, this is the final question before we go. I think it's the final question before we go into a tie break. No, it's not. We've got two. How much is the global space sector said to be worth by 2030? Is it A, left hand, £100 billion, B, right hand, £200 billion, C, both hands, £300 billion, or D, no hands, £400 billion? Have a think. 3, 2, 1. The answer is £400 billion by 2030. So a significant growth from where it is today. It's a fast growing sector. And again, another really exciting reason to get involved in the space sector in the future, because it is fast growing. We need highly skilled people, and it's super interesting. Okay, final question. What percentage of our climate data currently comes from satellites? Is it A, left hand, 30%, B, right hand, 40%, C, both hands, 50%, or D, no hands, 90%? Have a think. And 3, 2, 1. The answer is 50%. Okay, so hopefully there's still some students standing across the country. What I would like to do is ask the teachers to give a house point or a merit or whatever you give as a reward in your schools to any of the students who are still standing. But what I'd like to try and find is an overall winner, a school that will win the competition overall. So I've got a tiebreaker question. So any school with students still standing, you can enter the tiebreaker question by asking the students this question. So what is the speed that Launcher 1 needed to reach to safely deploy the satellites into low Earth orbit? So there's a very specific speed that the satellites needed to get to be able to be up in low Earth orbit and to be able to sustain being in low Earth orbit. So what I'd like you to do is ask your students and then type into the chat box. And if you could add in your school name and your guess, and then we will say who's got the closest to the overall figure. So I'm going to stop sharing my slide now and come back to the main screen. And then I'll be able to see the chat box and hopefully see some of the answers coming in. So I'll give everybody a minute from here just to get their guesses in. You see them, and then after a minute, I'll give you the answer. So we've got a couple of guesses in so far that I can see, which is great. I'm going to have to do some very quick maths as well, on who's got the closest. Cool. So I'll give everybody another sort of 30 seconds. Ten seconds left to get your answers in and submitted. Great. Okay, so we've got a tie for the closest. So the actual answer is 17,500 miles per hour. And that's the speed where if the satellites in low Earth orbit are traveling at 17,500 miles per hour, the Earth's gravitational pull is not strong enough to pull them down out of orbit, but is perfectly strong enough to keep them in orbit so that they're going around our planet at that speed. If you're in a further away orbit, so something like geostationary Earth orbit, which is about 36,000 kilometers up, the satellites only need to be traveling 6,000 miles per hour because the Earth's gravitational pull is so much less in that area to be able to keep them in that orbit. So the two schools that have won, we had one school who went for 15,000, which is Jersey College Prep 5T, and we had another school who went for 20,000, which was Jeanette's Park. Which I'm not sure if that's the name of the school or the name of the person who entered it, but you two are the winners. So if you can give your students another sort of award for that, that would be great. Okay, hopefully you guys enjoyed that. Hopefully it worked and it wasn't too carnage in all of your classrooms across the UK. Happy to now pass over to Lisa and then go on to any questions that you have.
Thank you, David. Well, I must admit, I didn't do that well in the quiz, but I got a few right, I think. So I was listening, but I'm sure the students did far better than I did. So thank you. That was really, really interesting. And we've had so many questions coming throughout the actual presentation. So I'm going to hand you over to my colleague Sophie, and she will put those to you.
Okay.
Thank you, Lisa. Okay, so our first question that came through was from Max from Mr. Thompson's class. Why do you love space and how did you get into a space career?
Hi, Max. Thanks for your question. I love space because it blows my mind every day. I feel like at the moment we're in a new space age. So, you know, we had the space age where they were trying to land the first people on the moon. Now we've got things like the James Webb Space Telescope, which are taking really detailed images of our very first existence, potentially finding new life on other planets. We're looking at the next Artemis moon landings in the next couple of years, and then looking at potentially having a manufacturing base on the moon. And then also the way that satellites are benefiting us here on Earth every single day, whether that's with faster communications or with looking at our environment or making industries more efficient. I just think space is so cool and so interesting. And to be honest, I was never hugely interested in space when I was younger. It only came about in the last sort of 5 to 10 years when I first heard about the spaceport being set up in Cornwall. And I really wanted to get involved because I saw an opportunity for really positive development in the county. And what I wanted was high paid, high skilled jobs for young people to be able to work towards and aspire to. And that's why I wanted to get involved, because I wanted to work directly with the students. So my job is sort of multifaceted in regards to I work directly with students to talk about space and to engage them in science, technology, engineering and maths. I work with the colleges and the universities to look at course development, to work out what courses need to be developed. And then I work with the businesses to look at what skills they need in 5 to 10 years time, so that we can plan now to make sure that there are people coming through with those right skills within the next decade. So it's a pretty cool job. It's a really exciting thing to be involved in. And I think space is so exciting.
Brilliant, thank you. Yeah, I'm also very excited about this idea I only heard about today of manufacturing on the moon. I could ask you lots of questions about that. Anyway, so our next question is from Tia and Callista from Miss Marshall's class, and it says, what is the process of a rocket going to space?
What was the process of the launch of one rocket going to space?
Yes, of a rocket going into space.
Yeah, so with horizontal launch, the 72-foot rocket was strapped under the wing of Cosmic Girl, the Boeing 747-400. That will fly up to 35,000 feet, which is the same sort of height as if you were going to fly from the UK to the US. That would then drop 5,000 feet when it's getting close to the drop point. So it will enter something called the runway, which means that it will circle around a couple of times. Then just when it's ready to release, it will drop about 5,000 meters and then pull up. And then when it's pulling up, then it's facing upwards. It will release the rocket. The rocket will drop for 5 seconds, and then the first stage of the rocket will ignite, and that burns for 3 minutes. Then that first stage of the rocket falls away, leaving just the second stage and the nose cone where the satellites are held. And then the second stage will burn for 6 minutes. And then it will get up into space, and then it's in a clamshell fairing. So it's called a clamshell fairing because the protective shield over those satellites opens like a clamshell, falls away, and then the satellites are inside and they're in a spring-loaded container, and they get spring-loaded out into space. And that's how horizontal launch works.
Brilliant. Okay, our next question comes from Rose at Jersey College Prep, and she's asking, how much does it cost to send a rocket into space?
Oh, that is a great question, Rose, and not one that I'm privy to know the answer to. So as a spaceport, we actually work very much on the infrastructure on the ground, and it's the launch companies who manage sort of the business case on how much it costs to launch and how much it costs to launch each satellite. So I'm not 100% certain on that answer.
Okay, there's something maybe that Google might tell us. I don't know.
I don't think it tells it very readily, because I have had a look in the past, and they keep it pretty tight to their chests in regards to how much each company charges.
Okay, I'm sure it's a lot of money. Okay, so our next question comes from St Mary's Catholic Primary School, and they are asking, have you ever been to space, or would you like to go to space?
I have never been to space, and up to last year I would always say I would definitely want to go to space, but I've recently had a child, and now my sort of viewpoint has changed slightly. I'd love to do it after it's been proven many more times, but at the moment I'm quite happy with my feet on the ground.
Okay. Hadlow Rural Community School, they're asking, what's the average weight of a rocket?
Oh, the average weight of the rocket. So the rocket for Virgin Orbit was 30 tons, and that's about the maximum weight that you can actually put under the wing of a plane. Whereas for vertical launches, they can be much heavier. So if you follow Elon Musk and SpaceX, he's launching his Starship, or attempting to launch his Starship. And for example, the Launcher 1 rocket had one engine at the back. The Starship rocket has got 36 engines at the back, which can give you a bit of an idea for the scale and size of that rocket. So that will be the largest rocket ever launched. I'm not sure of the exact weight, but that'll be a huge game changer in the industry if they can actually launch that into space. And that should be going up, or the next attempted launch should be sometime soon. So well worth having a look and trying to stay on top of that, because if it is happening during school time or lunchtime, it'd be or after school, it'd be well worth watching, because it's always interesting to watch those live streams.
Fantastic. Okay. Alex is asking, do you collaborate with NASA?
Hi Alex, we so from a launch capacity, not so much. However, we have had a speaker from NASA come and speak to some of our students that we had on work experience, and we do take part in some webinars and some activities with them, but not so much in regards to launching together and sort of developing the business together.
Okay. So Timmy from Sycamore class is asking, what is the maximum speed of a rocket?
That is a very good question, Timmy. I'm not totally certain what the maximum speed of the rocket will be once it's in space. Like I say, for low Earth orbit, the speed that needs to be reached is 17,500 miles per hour. But if you are in space and then you put the boosters on the rocket to fly without gravitational pull, you could get up to significantly faster speeds.
Okay. So here's an interesting question from Hadlow Rural Community School. Have you thought about the greenhouse gases that are emitted from a rocket launch?
Yeah, very much so. We're attempting to be the greenest launch site in the world, and there's still a big challenge in regards to space debris. So sort of space debris and environmental challenges are the thing that the space sector has challenges with. I think in regards to the environmental challenges, I think the argument for the benefits that the satellites that are being launched that give us on Earth, just GPS has saved something like 20% of emissions from driving, because of the efficiency that they offer to people being able to drive. And I think that's the sort of cost benefit analysis in regards to launching into space. And more companies now are looking at greener ways to launch into space, so greener fuels. I think we're still a way off. Actually, we're probably a decade off, I would say, having a truly green way of launching into space, because of the amount of effort that it takes to get away from our gravitational pull. But horizontal launch does get away from that first 35,000 feet of gravitational pull, which is beneficial.
Okay, and this next question links in quite nicely. So South Church High School are asking, why doesn't a rocket fly out of orbit?
So the rockets don't really, once the rockets get those satellites up into space, their job is done. They tend to burn up in the atmosphere afterwards. It's the satellites themselves, and the reason they don't fall out of orbit is because of the speed that they're going. So like I said, 17,500 miles per hour. The Earth's gravitational pull isn't strong enough to be able to act on that satellite, enough to be able to pull it back down into the Earth's atmosphere. It's just enough to keep it into that exact orbit, so it's going around the Earth in the same distance away all of the time.
Okay. So I've got loads more questions. If you're happy to keep going for a little bit longer, it is 10 o'clock.
I'm happy to.
Yeah.
Yep.
Okay. So the next question comes from Maudsley St. Peters. Do you think there are other planets in our galaxy?
Do I think there are other planets in our galaxy?
Yes.
But I wouldn't rule it out. I think there could be there could be planets on incredibly long orbits that haven't been identified yet, but I think it's more unlikely than likely.
Okay. I've got a question from Smarden School. Why did you choose a 747 to launch the rocket?
So the 747, Virgin Orbit chose the 747 because it was actually a Virgin Atlantic plane. So it used to take people on their holidays, which is why it was called Cosmic Girl as well, because it was called Cosmic Girl prior to Virgin Orbit having it. And it's one of the larger planes. So by using the largest plane, or one of the largest planes possible, you're able to have the largest rocket strapped to it as possible as well.
Okay. Palmer's Cross Primary would like to know what did they build the rocket and satellites out of?
So the satellites, aluminium is the core material generally, because it's light and strong. The rocket, carbon fibre, again, is a key material within that rocket structure, and carbon fibre is that amazing mix of being light and strong and being able to protect the fragile payloads that are inside.
Okay. Janet's Park School have asked, we've been reading a book that says you need to have flown planes before going into space. Is this true?
So there's a few common routes into the space sector. Pilot is one. So Tim Peake, our British astronaut, he was an ex-pilot and helicopter pilot. But also other routes include medicine and also research. So you don't necessarily need to have flown planes before, but it is a fairly common route through into becoming an astronaut.
Okay. I've got so Harrison from Mrs. Filson's class is asking, how do people eat in space?
Hi Harrison. So people eat in space with food that has been sent up from Earth. And this will be packaged food. So if you've ever seen sort of army rations, it'll be very similar to army rations, and it'll be sort of vacuum packed. And then when they get it up onto the International Space Station or into space, they then hydrate it and then are able to eat it. I don't think it's the best food known to man. And I think a lot of astronauts, when they come back, are looking forward to a hearty meal, but it is enough to be able to sustain them and give them exactly what they need when they're up in space to ensure that they survive.
Okay, great, thanks. Sorry, apologies, that actually says from April in brackets. Okay, so Harrison or April, thank you. All right, for time, Lisa, can we have a couple more, do you think? We still got people online, so
we still have got a lot of classes online, so I think maybe one or two questions, because David will need to go and do his day job too.
Okay, so I've got a question here. It says someone's heard that space smells like burnt steak. Is that true?
Well, they've heard correctly, apparently. So I did a broadcast with Tim Peake recently, and he said, yeah, space does smell like burnt steak. So when they've been out on a walk on the spacewalk on the International Space Station, once they've come back into the airlock, and they've opened the airlock, it smells like burnt steak coming off of the astronaut suits, and they're not entirely sure why, but yeah, apparently so.
Okay. Palmer's Cross Primary asking, how long does it take to get into space on the Cosmic Girl?
So you wouldn't get into space on Cosmic Girl, because that Cosmic Girl is the Boeing 747. So that's the plane, so that doesn't go into space. But the rocket itself, so once that drops from Cosmic Girl, that took about 15 minutes to actually get up into space.
Okay. So somebody, I think I've read a couple of questions about when is the next rocket launch going to be from the UK soil, from one of the spaceports?
So likely to be next year or the year after, and probably going to be Shetland or Sutherland in Scotland. And I think for Cornwall, so the horizontal launches, Virgin Orbit were probably 5 years ahead of all of the other horizontal launches around the world. So we're in talks with many of them, but they need to prove their technology prior to be able to launch with us.
Okay. I think we've got time for one more question, Lisa.
Yeah, let's go for it.
Okay, so I've got the question from Sam. What happens if a satellite breaks down?
Yeah, great question, Sam. So Virgin Orbit's whole business, or a large part of their business model, was on the ability to replace broken down satellites. Because by launching horizontally, you can fly north to get to a polar orbit, you can fly south to get into an equatorial orbit, but the market isn't necessarily quite there in regards to the demand for replacing the old satellites. But that is what can happen. A new satellite can be launched and replace that broken satellite in space. However, there's also a company called D-Orbit, and they're looking at taking up a new fuel cell. So if it's just the battery that has run out on that satellite, D-Orbit are looking at taking up a new fuel cell to actually dock onto that defunct satellite to give it a new lease of life. And that's much more relevant to satellites in the geostationary Earth orbit. So they're much larger, much more expensive satellites than the satellites in low Earth orbit.
Okay, I've literally got one more question because I really want to know the answer to this as well. So anyway, it's come from Mr. Thompson's class. Where did the idea come from to carry a rocket on a plane?
So it's not totally new. So there was a company about 20 or 30 years ago who attempted it, and then Virgin, Richard Branson, wanted to resurrect it and saw that there was an opportunity to launch in a different way. So there are a few different, we've got vertical launch, we've got horizontal launch. There's also a company in the US now looking at something called spin launch. So actually spinning a payload really, really quickly on the ground and then releasing that straight up to see if they can get that payload into space. So, new novel ways of looking at how to get those satellites into orbit.
Okay, great. Unfortunately, I think we have got to stop there. But I could talk about this topic all day because it's fascinating. And thank you for everybody who's put things in the chat and all the teachers and students watching in your schools. Thank you so much for your enthusiasm. Okay, so I'm just going to pass it over to Lisa now, who's just going to finish off. Thank you.
Thank you very much, Sophie, and thank you again, David. That was just so informative, so interesting, and we are sure our audience has been inspired to learn more about careers within the space industry. Thanks so much, as we appreciate that you giving up your time. You're a busy man, have lots to do. We thank you to everybody who joined us, as Sophie said, and enjoy the final day of World Space Week. We hope to see you all soon. Bye.
Thanks all. Thanks for all the questions.